All right, Anders, welcome to this sort of first interview in the Gesture Week, and this is a real privilege to have you in the hot seat. So, how are you today?
Oh, I'm very fine, thank you.
Yeah. Anders, you are our sort of senior research engineer on gestures and gesture control, and it's all about neural nets and machine learning, and it's a lot of buzzwords here. And what we really going to try to dig into is just how on earth does all this sort of work? For me, it's actually it's going to be quite fun because I don't know that, but in my previous life as a Master of Science, I sort of grew up with mathematical programming and developing heuristic algorithms. So it's actually going to be quite fun to talk to you about the nature of the algorithms that you are creating. But we spoke a little bit yesterday, and you said it's not really algorithms.
No, it's not algorithms, it's actually models. You fit a model to data. So the data is the real key here. And it's almost an art to design the models. But once you have the models and you have the data, it's basically just machine learning. You do some big number crunching, a lot of GPU computers, and then out pops a trained model. And that's what we use in our application. So that's the secret.
Yeah.
It's all in the model.
It's all in the model, but still looking at it, if you think of it, it's sort of if you think of an algorithm here, and an algorithm is sort of a set of it's sort of you follow basically execution step by step from A to B. That's sort of a lot of you execute a lot of steps, but what you create instead, when you're saying it's all about this model, it is like an algorithm, but it's a self-learning algorithm, isn't it? It's an algorithm that you create. What I've sort of understood with neural nets that you're working with is that you're trying to replicate a little bit how the brain works.
Yeah, that's how it started. So the original small neural networks, they are based on they're inspired by how neurons work, how they shoot out axons and these connections between the different neurons
in the brain.
Yeah, in the brain. But now we are looking more at computer vision, and they are more inspired by how actually our eyes are built with the receptive fields and so forth. So we call them convolutional neural networks. So basically, it's only about operations.
Could you say that again, Anders? What did you call it?
Convolutional neural networks. So the operation that is actually a convolution. It sounds fancy, but it's just a way to execute these models. So the models are based on the kernels that are slided over the image, and they produce a response. And then you do that over and over again, and out comes something that is actually useful.
Yeah.
So it's So
but even if it's convolutional, or if it's if we're using the brain, or if we're using sort of how the eye functions, it's quite interesting philosophically that we are actually replicating a biological thing like the brain or the eyes.
Absolutely.
It is almost like a network of nodes, isn't it? That are interconnected, and in that becomes the sort of the I don't know what you call it, but that's basically the neural net that is executing on a problem to try to make conclusions.
Yeah, absolutely. So the model is a neural network which consists of layers, and different layers of different operations. So convolution is one kind of operation, and they consist of parameters. And machine learning is all about setting those parameters. So what I do is that I design the neural network, the structure of it, but I don't know anything about what parameter goes into it. So that's the machine learning part. And that is actually step by step. You actually do it step by step, but that's not an algorithm. It's more about information flow. So you need to understand what kind of steps you need to take, but roughly, but you don't say that this step should do exactly this. So that's part of the learning.
Yeah. So we're setting up in a way I guess you said model, but we are setting up a model which are capable of learning. Learning how to what is a hand, what is, so we are teaching a computer with this sort of model of making right conclusions from image processing. Could you say it that way?
Yeah, absolutely. So it actually takes in the raw image, and it extracts features, and then it processes the features, and then it gives you the output in the form of some sort of a likelihood, so to speak. So it is very much statistical.
Yeah, that this is very likely to be a hand, or this is because you want to have I know you have words like false positives.
Oh yes.
Which is sort of that this is a false positive, I guess, is sort of that you conclude that this is a hand, but it's not a hand.
No, exactly.
That's a false positive.
Yeah.
No, it's and what we're using it for is that this model that you are building, and it's sort of a model that we first train by providing loads of data that this is the machine learning. So the machine is sort of getting a lot of data, and then where what is the right answer, I guess.
Exactly.
This is not a hand.
Yeah, so that's the key. You have label data. So you need to label it. You need to annotate it and say this is this gesture, this hand, or whatever. And then the machine learns the mapping between the image and that annotation. So that's really what's going on here. It's a mapping, and you need to provide it. So the model itself just contains whatever it needs to do. The filters it needs to extract information and do this mapping between the image and whatever you have labeled the image as.
Yeah, and one thing I know, I don't know if you, I guess you are not, but you have sort of your colleagues in your team. You're about sort of 10 people here working on gesture control, doing very advanced sort of image processing. But it's a whole process, isn't it, to in a very effective way collecting I don't know, is it thousands or hundreds of thousands or millions of data points that you could actually train the algorithms on. Could you say a little bit about that process that does the training? How does that process work, Anders?
Oh, we needed actually millions of images because we are looking at very advanced problems now. We're looking at the 3D skeletons, and deriving a 3D structure from a 2D image is really tricky. So we need a lot of data. And it also, like we said before, it needs to be labeled. So if you need to label it in 3D, and that's really challenging. So the approach we're taking is to have a lot of this data being synthetic. So we actually scan hands and animate them in software packages. And that provides us with these annotations for free. Now, of course, it doesn't look exactly like a real hand, so we need real hands as well. And then we do this very labelsome process of annotating them. So that's how we end up with millions of annotated images, which is what we really need to be able to pull this off.
Yeah. So after you have set up your model, then we expose that model, that neuron net, for all these millions of pictures yes. Where you can match, you're matching, I guess. What is the matching exactly? You describe that better than me. What are you matching? Are you matching the sort of that this is a hand and this is not a hand, or what is the matching going on?
It depends on which stage of the sort of the process we're in. So I'm looking at the very central stage where we actually have already found a hand. We know it's a hand, and we want to know what kind of skeleton or the pose of the skeleton of that hand.
Okay.
So I assume that it is a hand, and we need to regress we have 21 skeleton key points, and we need to put them as right as possible on the millimeter precision.
Yeah.
So that's what my network is doing, and it should be impossible to do it because the image that comes in is 2-dimensional, and the skeleton is 3-dimensional. So it's an impossible problem that we can't solve with.
But isn't this something you have solved, Anders? Which is just fantastic. That just with the 2-dimensional images, you are still being able to provide intelligence in a 3-dimensional world. Isn't that something you've cracked with your neural network?
Yeah, absolutely. Because I would say it's almost only a neural network can actually attack these kind of problems, because they are not mathematically sound. So if you use some classical algorithm, then you wouldn't succeed.
Yeah.
So this is.
Some people have asked me sort of what sets you apart, because you're not the only company in the world that can do sort of gesture control, and I don't know if you like this, Anders, but the way I described it for one guy was to say that I say like Zlatan, our soccer player Zlatan Ibrahimovic, and he used to say to a Premier League player, I think it was John Carew something in some you probably know.
I know.
What club was that he playing in, John?
I thought it was Valencia actually, but
Valencia. Okay, yeah. But it was in English. Okay, you might be. You probably know the story. But he's what you could do with a soccer ball, I could do with an orange. That's the Zlatan response. And I'm sort of saying that what we can do, what other people I guess could do with a lot of sensors and a lot of processing powers, we can do with an orange, because we can do it with so little 2D data. We have only a normal VGA camera, and we have very limited processing power, and we create magic out of that. Is that a fair way of putting it, or am I just dreaming?
No, I think it's very fair, because we are actually looking at very efficient algorithms running on only mobile CPUs. So we haven't done much to actually apply all these fancy NPUs and neural processing units, because it's still, if you want to support a lot of different devices, it becomes really tricky to over-optimize for one architecture. So we actually run on the standard CPUs, and we run really fast, and we can actually do a really good job with this limited amount of computing. Yeah. I think that's what sets us apart.
And the sensors as well?
We use only RGB, built-in RGB. Most other vendors, they use some stereo cameras or depth cameras and that stuff, but that just adds complexity to it. So
I know we have in our labs as well, working a little bit with dual cameras also, just like the eyes, that it's easy to see depth if you have dual cameras. But would you say, can we do the same thing with just one camera, or what would we add if we have a dual camera setup instead?
You can actually get absolute depth from a dual camera. So actually what you do is you take one step back. So you actually do some simpler solution for 2 cameras, and then you do a classical triangulation between those 2 images. But with one image, we go neural network all the way. So we actually get the actual result directly. And it's harder to do, of course, but that's what
but you have less constraints in that setup, because it's just, you can just use a normal VGA camera is what is on the mobile phone. It's a very cheap sensor that
absolutely, it's all everywhere. You can run it on everything that has just a simple RGB camera.
And I think that's the beauty with our solution, because it's when smart AR glasses going to move to consumer devices, you really don't want you can't have people looking like RoboCop.
Exactly.
Nice glasses,
Yeah, absolutely. That's really important to remember. People won't put any funny thing in their faces.
No. So just a sensor there. How about processing power, Anders? Would that kind of processing power that you need, would that be available, do you think, on the phone or on the glasses itself, or would you imagine that we have a tethered solution running on a mobile, or is this 5G maybe? So you compute on the edge in the cloud, or where is the computing power coming from for these kind of solutions that we have here?
I definitely think it will be on-device processing. I mean, I've been doing AR for almost 15 years, and there was always this dream about when 3G came around. I want to go and do AR on a server, but never happens. It didn't happen with 4G, and not going to happen with 5G either. So you really need to be on the device, and that's where we are today.
Why not for 5G, Anders? Why not? Because you know, I know 3G, 4G, but 5G has this concept of computing on the edge, which is sort of a new thing for 5G. So don't you think that could? But you are skeptical. I hear that. So
yeah. I haven't looked up very much about 5G, but I just know that with all this, with the development of hardware comes the demand from software, and it always exceeds the hardware somehow.
Okay, but so let's stay on the device. But would it be a tethered solution that you run the processing on your mobile in your pocket, and then you are seeing things in front of your eyes with smart glasses, or will it actually be a processor sitting, do you think, in the glasses itself?
I think to start with, it will be a tethered solution, because you don't have much use of a smart glass on it today. I mean, you will only have like one application or something. So if you have a very cheap smart glass connected to a very advanced phone that people are actually using these days, I think that's the way to kickstart this.
Yeah.
But in the long run, of course, I mean, when you can shrink the technology, it will be self-contained in a glass, I think, like VR headsets nowadays.
Are you having fun, Anders?
Oh, absolutely.
So how long have you, it's just amazing, because, my background is with algorithm, not as sort of fancy self-training algorithm as you develop, but I grew up with in my previous life, I was developing heuristic algorithm, search algorithms for solving NP hard problems, like designing mobile networks, as well as frequency allocations. We haven't had this chat, which is a shame.
Yeah.
So how long have you been with the company, Anders?
Well, it's more than 5 years now. I think it's 6 years in February. So it's been a while.
And you're happy here?
Absolutely. So these days we're actually really working along the way I want us to work. It's really streamlined process around deep learning now. So it was a little bit challenging when I started here, because anybody in the world knew about this deep learning. So I spent like the first few years just building all the platforms, and then once I managed to prove my point, and we actually so we have a really good process, a really good team now. So it's working really, really, really well.
Yeah, and I know I put you a little bit in quarantine because you were always dragged in a lot of directions to help, an industrial AR application here and another one there. And I said, well, let's just stop that. Let's just put you in quarantine. And it wasn't COVID. It was simply because I thought, let's give you the time to lift the quality of the product to really address consumer AR, because that's a much harder problem to solve than industrial AR.
Absolutely, because you don't have the same structured environment. So it will be very much harder to actually produce content for consumer AR. Yeah. And that will also make it harder to convince people to buy these AR devices. So it's
but it's more than just that that you will have a very the environment that these glasses will be used will be could be anything. It could be it could be very varying a lot, but it's also, you can't train a mass market. I think that's another challenge.
No, it needs to be intuitive.
If you have industrial AR, you can put them on a course. This is how you use this industrial, but a billion people, if these smart glasses is going to be the next sort of personal device, you can't train a billion people. You can't expect to do that. It needs to work out of the box.
Absolutely. So
and then I think the other thing is just that so people, you can't train them. That means also your algorithm needs to be it needs to be forgiving in the sense that if I do this, or if I hold my hand like that, or whatever I do to in some way interact, your algorithm needs to be able to cope with that. This is maybe hear a clicking I do here with my hand.
Yeah, it needs to be very, very robust. And I've learned from decades of user studies that people are different. They will interpret it their own way and do different stuff. So we really need to think about that. And that's what we have done as well. So we're recording very many variations of what these poses, like the pinch, what that could be. And then, of course, we need to test it as well. So on actual users. Yeah.
And then you have the fourth that we already talked about, that the form factor in consumer glasses needs to be, if you're in industrial AR, you can put people having a whole helmet on their head and a lot of processing power and 3 sensors or whatever, really. But we really just have to be using, just like Zlatan, an orange. That's what we can use.
Yeah, absolutely, because it will be hard, like I say, it will be hard to convince people to buy some expensive AR glasses before we have actually really good AR content. Yeah. So the first generation of glasses that will come out will probably be very low end. So we need to really work on those. So we need to be able to work on a single sensor and a single CPU. Yeah. Possibly tethered to a phone.
Yeah. And I guess that's what you're saying, that our architecture, that's what we have focused on. And I know you guys had took the product from being great for industrial AR, but we just took on all the challenges that we just mentioned for consumer AR, which is sort of a harder thing to
absolutely tackle. Yeah. So that's why I like to do it. You solve the hard problems when you have the chance, and then everything else will be easy once you need to do it.
So how did you come across? You said you sort of seem to have known deep learning, this kind of machine learning type of thing, deep learning, and long before many other people under. So how did you come across it? And what's your background? What planet are you born on?
Actually, grew up not that far from here, and then I spent 10 years studying media technology. I did a PhD in mobile computer interaction, and I was basically the first guy in the world to realize AR on mobile phones, and the very first Nokia phones with cameras. But because that was so new, I only did user studies or the mobile computer interaction, because that's what was new, unique about it. I couldn't really do computer vision, which I wanted to do. So when I started to work, I moved to New Zealand. I started to work with computer vision and building the AR solutions, and then I stumbled on machine learning. I did a Stanford online course, like so many others. It's a really great one. And then I saw that those very most difficult problems in computer vision could be tackled much better using deep learning, and that without even considering what has been done for 50 years in computer vision. And that blew my mind. Wow. I decided to work with deep learning and do whatever it took to do it. But back then there were very few people who knew about it. Those people that have done degrees in it, they started to work on Google, and I returned to Sweden instead. And I think there were 3 positions in all of Sweden that they even mentioned anything like this machine learning. It was mostly in statistics. So I came to Crunchfish on basically my merits in the AR or in deep learning. So it took a while for me to prove it, but now there's
even here. So we were a little bit, just like everybody else, we're doing more algorithms and not sort of these kind of self-learning neural nets models that you as you're saying, this is the approach that is revolutionary in a way.
It is, because it scales. So it scales with the data and it scales with the processing power. And there's basically no other approach to problem solving out there that does that.
Yeah.
That's why it's so important and why it's revolutionizing everything.
Yeah, so it's sort of a new paradigm, basically.
Yeah, it is. It's called software 2.0. That's how you can see it.
Yeah. No, I can tell, Anders, that you, even if we haven't talked like this, funny days that we do it on video the first time we actually do. But I've seen you, and we met sort of every Friday breakfast, and every week there is sort of progress here. So I think you're doing a fantastic job with your whole team as well. So
it's a team effort.
Yeah, no, it's great. And otherwise, sort of on your sort of personal level, you're a fun guy, because you climb mountains, and you throw yourself out of airplanes with parachutes. I guess it's not sort of Yeah, you have a parachute at least. You do.
Absolutely. Very fun one.
Yeah. So where have you? What mountains have you climbed, Anders? That you would are you proud of?
I was very much drawn into mountaineering when I lived in New Zealand, but then I went to Nepal and climbed Island Peak.
Island Peak.
Island Peak.
I've been at the base of Island Peak, but I'm you know, I walked to Everest Base Camp.
Oh yeah, it's a good one.
Another time in another trip to Nepal, I did roll valling, but Island Peak is, I'm scared of heights. And Island Peak wouldn't. I don't think I could do Island Peak.
It was a pretty tough one, but it wasn't that exposed. But the mountain I did after Island Peak was Matterhorn, and that's a completely different story. That is really exposed, so you actually just look down to in the abyss. But that's awesome. That's my problem. I'm sort of more proud about Matterhorn, but Island Peak was very tough as well. But then I couldn't really figure out what to do. I want to do Ama Dablam, but it's a huge challenge. So right now I'm just looking at ice climbing. I went down to do frozen waterfalls in Italy. That's also a really great experience.
Yeah. I know Ama Dablam is sort of because I've done a lot of these hikes with Anneli Pompe. Women, I've done all my hikes is with her. I've been Kilimanjaro and I've done Everest Base Camp, and you walk into Everest Base Camp, you have Ama Dablam.
Yeah, it's amazing mountain. It's the Matterhorn of Nepal.
No, exactly. Yeah, no, and she did that. I think the year after we did Roll Valley, which is another valley there in Nepal, and but it's really beautiful. It's one of those just like Matterhorn. It's a beautiful mountain.
Yeah, it's very beautiful, but also one of the hardest thing you can attempt to climb, actually. So I knew my limits there, but because it is a really dangerous sport. And like we're talking about a little bit, I have another sport right now, which I dedicate myself to, that's skydiving. So there's a lot of efforts into that now at the moment.
Skydiving. What's the difference between skydiving and parachuting?
Skydiving is you're more looking at the free fall. I mean, it's just the two different words for the same thing. I mean, you obviously need to land using a parachute at some stage, but the skydiving is that more like emphasize the free fall, because that's where you actually fly. You can fly like 500 kilometers per hour, and you can just do whatever you want.
Wow.
Yeah, it's just amazing. So
how are you accelerating up to a certain speed? Because I guess there would be a balance at one point between the sort of the air that's sort of stopping you in a way from accelerating more, and then the gravitational power. Are you coming up to some sort of? You said 500. Was it 500 kilometers per hour? Is that
it should be. I mean, the world record is 600 kilometers per hour, but that's a discipline called speed skydiving. So that's all about the speed. So what I do, I fly vertically. So I fall much faster than if you just do a tandem and you're on your belly. So I do head down and head up and everything in between. So it could be.
Is there any insurance on this? Because I'm getting worried here. Is there any insurance that you maybe pass out just by accident and you forget to pull the?
There is actually called an AAD, automatic activation device. So if I pass out, that will release my parachute, activate my reserve parachute. So. Yeah, it's much safer than people think. I think it's even safer than biking, but don't tell anyone, because then it doesn't sound that cool anymore.
No, but it's certainly for a guy like me. I'm sort of like adventures as well, but I am afraid of heights, and I could not imagine doing head down skydiving. I tried it in Brazil. I was there during the World Cup in Rio, and I sort of did para. My family did. They all did. Let's see. They did paragliding.
Paragliding,
They just ran out of a mountain. They just had 4 paraglides. So they asked if one of us could do parasailing. which is I guess that is with parachute, isn't it? Parasailing.
Yeah, I think so. I did a paragliding introduction course the other year, so
yeah,
I should know.
No, it's but as I said, they had one of those go cams. GoPros that is called, and I saw my face running off that cliff, and my face just said, my whole body says no, but then you calm down a little bit when you're airborne, but my body didn't want to do that. You can tell my face. I've never had such a funny face in my life, I think, running off a cliff in Brazil.
No, but it is a mental challenge. That's what I like about it. So basically, I mean, the first jumps are really scared, and after 10 jumps, you start to wear off a little bit, the scare, and then it's just the awesomeness left. And then it takes, I mean, I've done almost over 1,000 skydives now, so I'm...
Wow. Where do you go for these skydives? Is that here in Sweden, or is it somewhere?
I go to a drop zone outside Eslöv, so it's very close from Malmö. And then I travel also to other places in the world, like Slovenia is amazing in Boves, and then I went to California the other year to do camp. So I'm then going to go to Iceland this September. I'm going to jump in the wild over Iceland, so that's going to be amazing.
Wow. I think we have to take out the life insurance on you.
Yeah.
No, Anders, this has been great. Thanks for sharing sort of insight on what's happening here. I just love your work. Really impressed. As I said, as an algorithmic person myself, but I never actually. I'm too old for when the whole new paradigm with neural nets came about. It was actually. When I sort of left developing my own algorithms, the term was there, but it was really virgin, very early days.
A lot of people missed out on it because the neural networks were actually dismissed. We call it the AI winter because people dismissed neural networks. But once we have all the data and we have the computation, neural networks came back and just took over everything. But it's never too late to look into it again.
Yeah, I know. But right now, I'm busy with digital cash, so I'll do that first, and then food waste, and so I'm sort of have some other challenges. But I'll come back to. I had one idea, Anders. This is me thinking about this, that your algorithm applied to, or your thinking of a model on how that works applied to. National economy to try to model basically the economy in a country, or how sort of companies they become almost like every node is a sort of a company, and also people, and you sort of model that as sort of a how they interact to each other, because I sort of understood in neural nets there are something called a bias, that you can put a system-wide bias, and that I'm thinking of that as almost like the government coming with a reform or something, changing this sort of structure for everybody. And if this neural nets, as you are an expert on, I think, why don't we go out and try to win a Nobel Prize here? Because I think the Nobel Prize for economy would be probably coming to someone who can crack and model an economy with this new paradigm. Wouldn't you think that would be a fun thing to do?
That would be, yeah.
We just have to go to Stockholm to pick up the prize.
Yeah, exactly. But, that was it would be a fun trip. I can do some wind tunnel flying once in Stockholm as well.
Yes, we'll do that. No, that's good, Anders. Let's talk about winning Nobel Prize over breakfast instead of here now. But I really appreciate you being at Crunchfish, Anders. I think you're doing an absolutely amazing job, and I'm really happy that you're having fun. And I am scared of all your personal activities. I think a life insurance might be in order, but as you said, maybe there are safety precautions that we deadly people don't know about. So it's perhaps not as dangerous as you think it would be.
No.
Thanks a lot, Anders. Take care then. Cheers.
Thank you.
Cheers.